Problem solving with rational equations. Solving problems using rational equations, a couple of steps. Number one, you're going to read and reread the problem until you understand what's going on. Number two, you're going to translate, which means you're going to set up any equation. And then you're going to solve the equation, and then you're going to interpret. In other words, you're going to check to make sure your answer makes sense. And then state your answer to the question. Alright, so for the first one we have the quotient of a number and 9 times its reciprocal is 1. Find that number. So we need to turn all of these words into symbols. So the quotient of a number and 9 times its reciprocal is 1. Quotient tells us that we're going to have a division problem. Reciprocal tells me that we're going to have fractions, and is tells me we're going to have the equation or an equation. So the quotient means we're going to divide two things, and then the two things that we're going to divide is a number and 9 times the reciprocal of the number. So if our number is n over 1, the reciprocal is going to be 1 over n. And that's going to be equal to 1. So now we're going to do the math. So let's simplify. The 9 times 1 over n is going to be 9 over n is equal to 1. And then we can't divide fractions, so we're going to change flip. So keep the first one as is, change division to multiplication, and flip that second fraction. And then we're going to multiply, so we have n times n, which is going to be n squared over 9 is equal to 1. And then if we continue to solve, we're going to multiply, I'm going to multiply through by 9 to get rid of that fraction. So coming up here, we're going to have the 9's are going to cancel out, so I'm going to have n squared is equal to 9. And then I have a quadratic, which means I have to get it set equal to 0, so I'm going to minus 9 from both sides. And then I'm going to factor. So I have n plus 3 and n minus 3. Set each one of these equal to 0. And you're going to have n is equal to negative 3 and n is equal to 3. So now we need to make sure that this answer is good. So if I plug in negative 3 here, I'm going to have negative 3 divided by 9 times 1 over negative 3 is going to be 1. So that's going to turn into 9 divided by negative 3, which is negative 3. And negative 3 divided by negative 3 is going to be 1. So just check your answer and make sure it makes sense. Same thing with the 3. If I plug 3 in here, I'm going to have 3 divided by 3, which is still going to be 1. Okay, here's another one. An experienced roofer can roof a house in 26 hours. A beginner roofer needs 39 hours to do the same job. How long will it take if the two roofers work together? Well, we have a formula that is putting the amount over the time. So quantity is equal to the amount over the time. And so an experienced roofer can roof a house in 26 hours. So we're talking about one roof in 26 hours. That's for the experienced roofer. And then we have a beginner roofer can do the same roof in 39 hours. And so the question is, how long will it take if the two roofers work together? So we want to know, how long will it take to do that one roof if they work together? Well, if they're working together, then we can add their rates together. So the rate, I guess we could put that, your rate is equal to quantity over time. So we're talking about one roof in how much time. And we have two different people. We have the experienced roofer and we have the beginning roofer. And so here's the experienced roofer and here's the beginning roofer. Now let's talk about this. If it takes the experienced roofer 26 hours to do a roof, and it takes the beginning roofer 39 hours to do a roof, and they're working by themselves, but if we put them together, if those roofers start working together, how much time do you think it would take those roofers to do one roof? If the experienced roofer can do it in 26 hours, and then we have a helper coming along that can do a roof as well, it's going to take this experienced roofer less time to do the roof. So if they're working together, I expect my T here to be less than 26 hours because they're working together. So if he can do it in 26 hours by himself, then working together, it should take less than 26 hours because now he's got some help. So let's see what happens. So for here, I have an equation that has fractions in it, so we can find a common denominator if we want to, or we can multiply through by the common denominator, which is, I think, is what I'm going to do. So again, remember, to find a common denominator, you have to break these down into their primes. So 26 is going to be 2 and 13, and 39 is going to be 3 and 13. So the common denominator is going to be what's in common, which is the 13, times anything that's not in common, which is 2 times 3 times t. And when you do that, you're going to get 78x. So I'm going to multiply each one of these by 78x. So when I do that, if I multiply 78x times 1 over 26, I'm going to get 3x, or I guess it would be t, using the wrong variable. So that would be 3t plus 78t times 1 over 39 is going to be 2t is equal to 78t times 1 over t is just going to be 78. And so I'm going to have 5t is equal to 78. Divide both sides by 5, and you're going to get t is equal to 15.6 hours. 15.6 hours. And that makes sense because it's less than the 26 hours that it takes the experienced roofer to do. Alright, last example. The speed of a lazy river's current is 5 miles per hour. A boat travels 20 miles downstream in the same time as it travels 10 miles upstream. Find the speed of the boat in still water. So this one is going to be distance equals rate times time. Distance equals rate times time. So if I set this up and I have the boat going downstream and I have the boat going upstream, okay, distance equals rate times time. So let's talk about the things that we know and how to set this up. So I know that the distance going downstream is 20 miles. The distance going upstream is 10 miles. Now the rate is going to be basically what we're looking for, which is going to be for downstream, we have the current of the river helping us. So our rate is going to be whatever the rate is plus 5. And then going upstream, the rate of the river, the current of the river is going against us. So that's going to be r minus 5. Now, if I take distance equals rate times time and I need to fill in time, what I'm going to do is I'm going to divide both sides by r, and so I get t is equal to d over r. And so for my downstream, I'm going to get 20 over r plus 5. And for upstream, I'm going to get 10 over r minus 5. Now it tells me that a boat travels 20 miles downstream in the same time as traveling 10 miles upstream, and it's looking for the speed, find the speed of the boat in still water. Okay, so I know that I have an equation that I can set up by putting these times equal to each other because it's the same time. So if I have 20, I think I'm going to back this off so I have some room up here. So I'm going to have 20 over r plus 5 is equal to 10 over r minus 5. So I have one fraction set equal to another fraction, which means we're going to butterfly. So we have 20r minus 100 is equal to 10r plus 50. And you know how to solve this. So if I minus 10r from both sides, I'm going to have 10r minus 100 is equal to 50. And then if I add 100 to both sides, I'm going to have 10R is equal to 150, and divide both sides by 10, I'm going to have R is equal to 15. And so my rate is going to be 15 miles per hour. So that is the speed of the boat in still water. Now we're talking about minus the current, so you have 15 miles per hour. So that should make sense though, because going downstream, I'm going 20 miles an hour. Going upstream, I'm going 10 miles an hour. And so if I minus the current here, that's going to give me the 15 miles per hour.